Hello, my name is Jean-Pierre Pichetti, and in this presentation, I'll be discussing Brain Scanology's research on identifying morphological subtypes in glaucoma using the GRAPE dataset. The GRAPE dataset is a public, open-source dataset originating from China that consists of fundus images of normal and glaucoma-affected eyes in both females and males. The core algorithm of our software, ShapeGenie, is the linearized compressed polar coordinates transform, otherwise known as the LCPC transform. The first step of this method is to outline the cup and the disc, since these are objects of interest, and ShapeGenie will find the smallest possible rectangle around this outline. The red dot marks the center of the radial grid where 71 lines are placed 5 degrees apart from each other. ShapeGenie will then calculate the distance from the edge of our outlined object to the center for every line in the radial grid, which is illustrated here in step 3. For this project, we did the radial grid processing method simultaneously for both the cup and disc outlines on every image. The distance of all intersections on the same grid line will be added together, and therefore the graph in step 4 will only have one y value for every x value. The fast Fourier transform is applied on the linearized system in step 4 to get a multidimensional representation of the shape in step 1. Optionally, we can use different types of indices, such as summing all of the bins from the previous steps in order to get a scalar representation of the shape. In addition to summing all of the bins, we also derive ratios such as the value of bin 2 divided by the value of bin 3. A very important detail is that ShapeGenie allows us to measure what we call pure shape. By resizing objects in a standardized method, we can separate the effect of size from the effect of shape. We made sure to constrain the aspect ratio when resizing so that the object isn't skewed. And pure shape is measured in a way that is dimensionless, meaning that even if objects are at different magnifications, we can still measure their pure shape objectively. A second important detail is that we standardize the orientation of the cup and disc before we measure their shapes. To do this, we use ShapeGenie to rotate every object so that its longest internal length is horizontal, and then resize the width of the cup and disc to 400 pixels. After this, the object is rotated 90 degrees clockwise before the radial grid is overlaid on it, which will then be used to find numerical representations of the shape. We standardized the alignment because we found that this provides cleaner data due to the fact that nature is inherently polar. For example, interior versus exterior. An important point is that for this dataset, we did not segment the cup and disc outlines because the dataset was already segmented by its authors. We have shown with 4 independent datasets that whether we outline the cup and disc manually or use the outlines provided by the authors, our approach is still effective. As previously mentioned, the radial grid processing will turn every shape into a multidimensional representation of 71 values. An analogy to better understand why we use a multidimensional representation is to think of one's age. For example, your birth date is a multidimensional representation of how old you are as compared to your age in years, which is a scalar representation of how old you are. Using this data, we did k-means clustering along with the elbow method to reveal any subgroups hidden within the data. Then we use principal component analysis to plot the data according to the first 2 principal components, while color coding the data according to the subgroups identified by the k-means clustering. So this is the actual representation of the previously mentioned data that was plotted according to the first 2 PCs. K-means clustering revealed 3 clusters for both females and males, and the different colors each represent the different clusters. For each of the 3 clusters, we created box and whisker plots of clinical data such as age, intraocular pressure, central corneal thickness, and OCT retinal nerve fiber layer thickness. There are 4 graphs for the RNFL thickness, and this is because the abbreviations S, N, I, and T represent the superior, nasal, inferior, and temporal part of the eye. The purpose of these box and whisker plots are to identify any obvious and meaningful differences between each clusters for the specific clinical variables. We identified a subtype specific to females, specifically the age variable, through the morphology of cluster 0. As you can see, the yellow highlights show the statistically significant differences in these clinical features. To confirm that the female-specific subtype is specific to females only, we did the same analysis on the male data. There were no evidence of a subgroup of men above 45 in cluster 0. However, despite the lack of a cluster 0 age-specific group in males, the three k-means clusterings have clinical differences as defined by the RNFL thickness. To confirm the 45 plus age group exists in females, we compared clinical features between women above and below age 45. With these box and whisker plots, we can see that there were many differences between clusters 0 and clusters 1 and 2 in the above age 45 group, as shown by the mean RNFL thickness and its individual components. Similarly, for the under age 45 group, there are some cases of statistical differences. However, the sample size for cluster 0 was particularly small, consisting of only 3 data points. Therefore, we took any conclusions about the differences between the clusters from this age group with a grain of salt. Unlike the observations found for the above age 45 group, for females, these were absent in the male counterparts. The mean RNFL thickness shows little to no statistical differences between clusters 0 and clusters 1 and 2. For the under age 45 group, for the males, the only differences found was with the RNFL temporal thickness. In conclusion, this study of the GRAPE dataset showed that our ShapeGenie software found 3 different morphological subtypes of cup and disc patterns in both females and males. However, the data shows that there was a more pronounced effect of this in females. Furthermore, within females, ShapeGenie found a specific type of cup and disc morphology in glaucoma patients that occurs due to sex and age, these specifically being females above the age of 45. It's important to note that this subtype was specific to females only and not males in the GRAPE data. And with that, this concludes our presentation. Thank you for listening.